In this lecture, we're going to build units from our buildings using the build unit command. Let's get started. Process we're going to take to do this looks a little like this. In our static project files, we're going to create a new scriptable object of type build unit action for each type of unit we want to build. So we'll have like a build worker action and a build air transport action, etc., for each unit we want. These will have all those same properties that we get from action base with the sprite, the int requires click to activate, and the unit scriptable object that we want to build. We've already made those worker and the air transport scriptable objects, and we're going to be extending that sum with a prefab game object and a float build time. Then on our abstract commandable, that's going to have a list of available commands, right? For like the command post, we'll have the build worker action assigned, and that unit SO on the build worker action will be that worker SO. Whenever we get to the airport building, that will have the build air transport action, which will also be referencing the air transport unit scriptable object. And that build unit action will know how long something should build based on that build time. And we're going to go straight into the challenge today. Create the build unit command class that extends our action base. This class will need a unit SO that's called unit as a field. And for the create asset menu, use the following: the menu name of buildings/commands/build unit in order of 120, and a file name of build unit. And don't worry about the can handle or handle yet. We haven't talked about how that's going to work, so don't worry about implementing those two functions. Pause the video, implement the rest of this class, and I'll see you back here in a couple minutes. Welcome back. I hope this didn't pose too much of a challenge for you. We did something very similar with the move command here. So in our commands folder, make a new file called build unit command. In there, we'll go ahead and put it in our namespace, GameDevTV RTS commands. We'll define it as a public class build unit command that extends the action base. I'll implement those two method stubs for can handle and handle so we get rid of the compile errors, but we're not going to touch those yet. And finally, we need to attach our field serialized field, public unit SO unit that has a public get and a private set. And this didn't want to suggest serialized field, so at the top I'll add that using Unity Engine. Then we need to attach our create asset menu, providing that file name of build unit, providing a menu name of building/command/build unit, and of course the order of 120. So this is all we were looking for here. It's really important that we know how to quickly create these because we're going to be making a lot of them. Now let's walk through the flow of how this is going to work. On the Actions UI, we're going to be finding from our abstract commandables selected units, which commands are available, and setting those up for the handle click. And we'll have an action selected event raised in that case. In our player input, whenever that action selected, right now all we're doing is assigning that active action to be that action. And we need it to maybe do a little bit more if we don't require click to activate. Let's go ahead and convert this from the single line function to a normal function by adding the curly brackets. And we can leave setting the active action to the EBT action. But if our active action does not require click to activate, then we're going to want to immediately handle that action. And just a little while ago, when we did handle left click, we're going to want to basically do all of this stuff immediately, as if the player just left clicked. So what we can do is take all of this stuff that's here right now and extract it out into its own method that we can then call above. And we highlight all that code, right click it and say refactor and say extract method. We'll move all of that code over to a new method. We can then rename that method to say activate action. And then back up at the top with our handle action selected, we can just call activate action, and these won't require raycast hit. So we can just provide a dummy raycast hit. The assumption then is that any actions that don't require a click to activate don't really care about that raycast hit. So having an empty raycast hit with no real values is totally okay. So we've got our entry point covered, but how do we tell if we can handle, and what do we do if we can handle this command? Well, in our base building, we're going to need to build that unit. So in our base building class, let's make a new public void called build unit that accepts a unit SO unit as the argument. And in here, we're going to want to instantiate that unit prefab. We haven't created that on the unit SO yet, but essentially all we're doing here is going to want to instantiate that prefab after some delay. So let's come over to our unit SO and attach a field serialized field, public game object, prefab with a public get and a private set. In addition to the prefab, we're going to want a build time. So we'll make a field serialized field public float build time with a public get and a private set, and set that to be something like 5 by default. Back over in our base building, now our compile error is gone because we have that prefab, but remember that we want it to take some time to build. Right now, as soon as we call build unit, that prefab is going to be instantiated, and that's not what we want. There are a few ways that we can handle this. The way that I personally like to do this is with coroutines. Coroutines are functions that allow tasks to be spread across multiple frames. And what we want to do for building a unit is effectively delay our execution by many frames until that build time has passed, and then instantiate that object. And with Unity, we have many ways for the execution to be paused for some specified duration, such as waiting for X number of seconds, waiting for X number of frames, and there's several more, but those are the two most common use cases. With that, what we basically want to do in build unit is wait for the unit.build time and then instantiate that unit prefab. So let's implement our first coroutine in this project. Coroutines, remember, are functions, so let's make it a private. And to define it as a coroutine, we want to say IEnumerator. We don't want the system collections generic. We want it to be just system.collections. If you try to use system collections generic, it doesn't work. So a private IEnumerator, and let's say do build unit, and we'll accept that unit SO. And what we want to do in here is tell Unity, we're actually not going to do anything for a while, so keep doing whatever you're going to do. We do that by saying yield, saying we're yielding execution, and let Unity know that they should be able to keep going. We're going to return our IEnumerator, and that's going to be a new wait for seconds. And we just need to specify how long we want to wait. And we can see here we want to delay the execution by the amount of time specified in seconds. And we want to wait for unit.buildTime seconds. So this line of code looks a little bit weird if you've never used this before. All we're doing is saying, Unity, we're going to yield execution. Here's the thing that's going to tell you when you should come back. And that's saying we're going to wait for some number of seconds, 5 by default. And what's really weird here is we have already returned something, but we're going to come back. These typically are executed in the update loop. So Unity will come here and say, hey, do I have any coroutines to execute? Yes. Okay, let me go through all of these, see which ones have yielded. And if the time specified or whatever condition is specified here on our IEnumerator says we should come back, even though we've returned, it's going to execute whatever comes after that. So it's a little bit weird mechanic from our standard programming where whenever we say return, nothing else happens after that, right? And then all we're going to want to do is instantiate this unit prefab at some location. So for the time being, let's say we're going to instantiate that unit prefab at this building's location with the default quaternion identity rotation. Now up here in build unit, how do we start a coroutine? Well, it's pretty simple. We say start coroutine and then specify which coroutine should be executed. That's do build unit. And we're going to provide that unit in there. There's a start coroutine that accepts a function call, which is our do build unit. So I know this looks a little bit weird. We just think of coroutines as functions that are queued to execute in our update function. All of those coroutines will be executed. We'll check if this condition, whatever it is, in this case, our condition is we want to wait for 5 seconds. If that ends up being, okay, hey, that time has passed or that condition is true, then we're going to execute whatever comes in here. In our case, we're going to instantiate some prefab. You don't have to immediately yield return something though. You could do some code here. So maybe to showcase this, we can add some debug.log statements. One as soon as we enter in the do build unit, and one immediately after our wait for seconds time has elapsed. Back in our build unit command, now we have all the things we need to be able to implement our can handle and handle. Do you know what should go in both of these? In can handle, context.commandable needs to be a base building. So we can say return context.commandable is base building. In handle then, we can say base building building equals casting context.commandable to a base building type, and then just say building.build unit and that unit. Very simple, straightforward command. Now let's come back into Unity. In our project panel, our units, buildings, let's go ahead and make a new folder. We'll call it commands, similar to what we did for units commands. And in there, right click, create. Now down here at the bottom, we've got units up here, AI actions move, buildings, commands, build unit. Maybe we need to change our AI actions to be AI commands so we stay consistent. We'll do that in just a minute. So our buildings are coming after our AI actions because of that order of 120. So let's go ahead and make our buildings command build unit, and we'll call it build worker. For the icon, we have a worker icon. Let's go ahead and use that. And slot 0 probably is where that should go. Let's leave that there. This does not require click to activate, and the unit should be the worker. Then if we select our command post prefab, let's give them that command. Build worker. And on our worker, we're going to want to make sure we assign that prefab. Let's go ahead and drag that worker prefab from the project panel over here to this prefab on the scriptable object. And let's click play and see if it works. We select our command post, our unit shows up. If we click on that and wait about 5 seconds, we see nothing happens. So something's clearly wrong. Well, in our player input, we're casting all of our selected units to abstract units. We probably want to make those abstract commandables since buildings can also issue commands. So before we activate an action, if we convert all of our selected units from iSelectable to abstract commandables instead of abstract units, let's see if that helps us any. And of course, rename this variable from abstract units to abstract commandables. If we come back to Unity and click play and bring up our console, if we select our command post and click on our command there, the build worker action, we'll see, hey, we started this coroutine, several seconds, 5 go by, build time has elapsed, instantiating the unit, and there's our unit right outside our building. Even though we chose to instantiate it at the same position as this game object, which is in the middle, because of the carving of the NavMesh obstacle, once we instantiate the object, it gets placed on a nearby location on the NavMesh. So that's pretty cool. However, we can see a couple small little things. One, when we click on this button, it goes away. And 2, if I click build many times, all of those units get instantiated. There's no concept of a building queue. And we'll take a look at both of those and do that little bit of unification about the naming that we talked about a minute ago on the next lecture. So when you're ready, I'll see you over there.